So, today's discussion, as you know, you don't have any homework this week. So, today's discussion is about approaching problems for your midterm, right. So, I will do 3 problems, majorly the 3 sections that you have encountered. First one is static stability, in which everything that is happening in the longitudinal plane is separate from what is happening in the lateral and directional planes. And then finally, we discovered, like we learnt about CG limits, trim conditions. This is like the third aspect of module 1, right, stability and their implications. So, I will show you, like I have some mock examples in mind, which I will tell you how to approach. So, you do not need to, like you can just simply watch the video later on and try to reapproach your homework problems in the same way if you haven't, which helps you in what do you say, active recall, and also some of the tricky things that Professor Taha could do it. I could warn you in advance, that is the best I can do for you. So, okay. So, most of the questions that you will see will be of this format. Lots of data, find 1, 2, 3. Okay. So, you are not supposed to look at this first in an exam hall. You are supposed to look at this first. So, let us understand this with an example. So, let us say that something was given in the data, I do not care. The first part of the question says find out the trim, find out the elevator angle in terms of the lift coefficient, trim lift coefficient. So, it is asking me that can I relate the elevator angle to CL trim. Then it is asking me find the most forward CG limit, for alpha max 15 degrees and delta elevator plus minus 25 degrees minimum and maximum. And finally, the question also says that show or illustrate static margin. So, I know that in the homeworks we have not deducted any score for diagrams or something like this, but in the exam we expect you to maintain a decent basic decency about how to make sketches. Like follow the pattern which is here, and please tell your people over Discord who haven't attended the discussion session that if they do not follow this format, they are going to lose marks, because this is important. Where did I keep my cap? Yes. So, now here some things, here 10, 20, how many ever data points may be given. If I wanted to confuse you, I could dump the entire data about the aircraft, which will not be required, right. So, what are you going to look at first? And also, have you been told about the cheat sheet concept, that you are allowed 2 sides of cheat sheet? Okay. So, my advice is break down your cheat sheet into these sections. The first, it is up to you whether you take my advice or not, it is on record. I am not responsible if you do not put in a formula. So, my first would be to go to lecture 1 and note down everything that is related to 2D CL and 3D CL, right. How we use kappa, aspect ratio, blah blah to convert 3D CL to 2D CL. This will be required or may be required, I do not know. Then what are the relations for epsilon? That is, epsilon is equals to epsilon naught plus d epsilon by d alpha times alpha, and other small things about lifting line theory which you should be aware of. Then the second part of the module is about longitudinal stability. What comes in longitudinal stability? We basically focused on lift coefficient and moment coefficient, right. And then we saw again and then we saw how many contributions in lift and moment in the longitudinal plane. Like each of them has contributions from 3 things. What are those three things? Wing, tail, horizontal tail. Sorry, what am I saying? Wing, tail and elevator. Okay, and which one of these is different, is an imposter in this group? In some sense, the wing. Why? There is something different about one of these things here. Yes. Why? Yes. Elevator is a way of giving an input or control. It's not just about stability. Okay, I told you that stability and control are two different aspects. Stability is that we want the system to come back from small disturbances on its own. Otherwise, you can imagine a pilot will always have to hold on to the stick all the time, and that would be extremely tiring. You can actually go and watch. I think there is a colored movie of Wilbur Wright making, like, not the first time he flew, but the second time he flew. You can look at that colored video and you can see that they have to control the stick a lot, because that plane is inherently unstable. So the pilot has to keep controlling so what happens is the plane keeps going in this mode, which you will learn about more in the upcoming dynamics part. And obviously you should note down contribution of wing to these two things, contribution of tail, contribution of elevator, and then the constant part and the coefficient part. Okay. Then comes the lateral directional and roll stability, right? Yes.
Can you write down the formulas
For each of those?
Yeah.
It's written in these lecture notes.
Oh. Okay.
Yeah. So these are uploaded on your Canvas, lecture 1 to lecture 6. Go down and note down the formulae. Lateral directional roll. So first of all, which has been my nightmare until now since my undergraduate, get your signs right, or at least make a table. Where the aileron deflection is positive, where elevator deflection is positive, what direction rolling moment is positive, and so on and so forth. Because I am pretty sure that there will be one question which either asks you the sign deflection of the aileron, or the sign deflection of the elevator, or the sign deflection of the rudder. If you get it wrong, 1 marks gone. And then again here also the other parts, rolling moment, rudder, and then their relations to like their contributions coming from rudder and aileron. Okay. And then what things affect, there is something special about roll. So remember that in roll you have been taught a lot of things affect roll. What are those things? Dihedral, wing sweep, wing position. Okay. And then there is the additional topic of wake vortex encounter, the example that we did last time, that what would happen if you had a large jumbo jet taking off, leaving out wingtip.
Your cell phone.
What will happen if a smaller aircraft flies into the wingtip vortex? Okay, you need to find out that if the rolling moment coming from the aileron is greater than or equal to the rolling moment from the wingtip vortices of the giant aircraft. Okay, is this clear? So now, assuming that you have this on a 2-page cheat sheet, I am going to keep it here, right? Assuming, yes.
You're saying that for that, given some parameters, you have to make the rolling moment from the ailerons larger than the.
Yeah, I mean, most probably you will be asked the question that whether the follower aircraft is going to survive the wingtip vortex or not. So to determine that, you will first go ahead and find out the rolling moment that is being induced by larger aircraft's wing tip vortices, and then this is the rolling moment that maximum aileron deflection will give you. So, if let us say that this was your small aircraft and suddenly you were caught in a wingtip vortex, then your aircraft has the tendency to roll this way, right, which means that you need to deflect your ailerons the other way and check if the maximum rolling moment that your aileron can generate, is it larger than this rolling moment. If not, then the aircraft is unsafe, it can't survive the wingtip vortex. Why did I pay for this? Okay. Now, any other doubts or questions before we move forward? So, you have practiced enough. The aim of today's discussion is not to get you to solve questions, you know how to do that. The aim of today's discussion session is how do you not lose your mind when you know that there is a timer on the wall. Okay? So, for that to happen, don't waste your time reading the data. There is no good coming out of reading that how much CL alpha is. Read the description at the start, that whatever is given, skip this data. This data is your toolbox. Until unless you look at what the problem is, there is no usefulness in knowing what the tools I have. Okay? My God. There is supposed to be, like, I haven't attached the tracker module, so it is not supposed to move. Is it happening because of? Okay. Does anyone have any doubt up until here? Okay. So, now what is the first thing that we need to find out? It is asking us that, okay, some configuration of the aircraft was given to you, some data is given to you. Can you express the elevator angle in terms of CL trim coefficient? That is, we were flying and due to some condition we had to engage the elevator. When do you need to engage the elevator? If you want to take a level flight, especially when you are flaring down, okay, then you need to engage the elevator because there is a positive moment because of the landing gear and you slowing down and flaps coming down. So, how do I relate them? What is the general nature of the formulae that you have seen? Some coefficient of moment or force is equals to some function of alpha or input, right? There is no alpha here right now, right? Which means that, but elevator is in effect, which means that I can write CL as CL naught plus CL alpha times alpha plus CL delta E times delta E. Can I do this? This is valid, right? And I know that there will be two contributions, wing and tail, and this will be coming directly from CL delta E. So, all these formulae will be here, should be in your cheat sheet, that what is the wing contribution, what is the tail contribution, so on and so forth. Now, okay, I go ahead and I look at my cheat sheet. You obviously won't have this 20-page cheat sheet, you need to note it down on your own. But yeah, so for example, let's look at, actually CL alpha is simply CL alpha wing. So, you will go and look at, is CL alpha wing provided to me or not? Now, you go and look at the toolbox, that where is CL alpha, right? And still you have to be careful, because here you are using which CL alpha, 2D, 3D? 3D. And if the question data has something like this, then what is this? 2D. Then you need to look for aspect ratio next. Can I get the aspect ratio? If I have the aspect ratio, then I can use the value 2 pi aspect ratio in CL to get capital CL. Okay? If nothing is provided, then what will you do? Let us say no information about CL was provided. So, for lift coefficient, you can always assume that If it is not provided, you can write down in your answer sheet that I am assuming CL equals 2 pi. Which CL? CL 2D, okay. Give me a minute. Okay. So, now I can assume that CL is 2 pi. Go ahead and find the aspect ratio and then calculate the 3D CL. Okay. So, first approximation that you should always keep in your mind is that if CL is not given, I can always make this approximation that CL is equals to 2 pi. Why can I make this approximation? Just to tell you the entire story, remember that this is only valid for a flat plate of 0 thickness, okay? And this is actually CL alpha, not CL, not the entire CL. I should correct myself. This is CL alpha, okay? Because CL naught, it depends upon the camber. For flat plate, CL naught is 0, okay? But if there was a camber, then the CL naught would be non-zero, okay? So, you go ahead and find out all of this. Now, what would be the first thing that would be required here? What else would be a problem here? So, okay, I got CL naught, I got CL alpha, I got CL delta E. Huh? Yeah, I still need alpha, right? How am I going to get alpha? Huh? Moment equation. Okay. Someone's catching on. I have two unknowns here, so I need two equations. Okay. Cm is equals to Cm naught plus Cm alpha times alpha plus now at trim, what is the value of CL?
CL?
Yes. CL trim. What is the value of CM?
0.
The way you found out these two, can you find out these two from the given data? Coefficients are not difficult to find. Please get this into your head. They are just giant numbers. You can do the algebra. You are smart enough to do that. Otherwise, you would not be sitting here. Okay. Again, the same thing. You are smart enough to go and find out. That is why you have been provided with a cheat sheet. Like storing that information in your head is not intelligence. You can just go and pick that data up and manipulate it and put it here. The part where you need to use your intelligence is that once you write the first equation, you should immediately see that alpha is not known to me. Alpha was not given. Maybe alpha is given, the question is simpler. But alpha may not be given. You need to deduce alpha. Is it possible to deduce alpha? Yes. Because whenever the word trims comes up, you always have two equations at disposal. So, if you get stuck in a question where trim is coming up and you are using only one equation, it is a hint that you need to use the other equation as well. So, excellent. We now have two equations in two unknowns. Can I go ahead and solve for delta trim and alpha trim? It is easy, right? Anybody who did not get this concept? Okay. Next, CG limit alpha max delta epsilon. So, basically it is saying that what is my maximum forward CG limit given that I have to fly at maximum 15 degrees and my delta elevator is going to be plus minus 25 degrees. So, first of all, when is this scenario going to happen? Landing, right? And at landing, again what is it asking me? Maximum CG limit. Maximum CG limit means, which means my static margin is highest, what changes with, so think about this way always for CG limits. So, H n, this is x n p minus x c g divided by c bar, right. This is equals to, this is equals to the any CG problem, any CG limit problem, if you do not write down all the 4 parts of this equality, you might get lost. Okay? So, sometimes this piece of information might be given to you, sometimes this piece of information might be given to you, sometimes this piece of information might be given to you. Got it? Yes.
Isn't it like C is equal to CM alpha over CL, which is equal to DCM over DCL?
Oh, yeah, correct, absolutely right. Yes.
What is HN?
Yeah, Hn is the notation for static margin. Any doubts up until here? Now, what are you going to do next? If alpha max is given to you and I want to find the most forward CG limit, should it be happening at a positive deflection or a negative deflection?
Negative.
Why?
Because that's like upward.
If you don't have confidence like me sometimes in the exam hall, go ahead and draw a sketch. If this was your elevator, this would how it look like landing, right? Your elevator won't look like this on landing, which means, and remember that downward is positive, which means negative. So, I think is there anything else left that you need which is not available to determine XCG limit forward? You know that alpha max has to be 15 degrees. You have already found out CL, CL naught, CM alpha, whatever is required, even the delta contributions. And you know that it has to be done at negative 25 degrees. Do I still need to do the arithmetic for someone? Neutral, what is the definition for neutral point? The definition of neutral point is that the moment does not change about it. So, basically it's like moment is always trimmed about neutral point. So, you know which part of the equation to use now? That is why CM alpha most forward varies, CL alpha won't vary. Okay? CL alpha is going to be a constant entity, but CM alpha varies with the location of the CG. Because how you take the moment, because moment is dependent upon the position from which you are taking the moment. So, if the CG itself is moving, the moment will also move. Okay? The constant part of the moment comes from the aerodynamic centers. So, they are not going to change with CG location, but the part that varies with alpha is going to vary if CG is varying, because moment is dependent upon the point from where you take the moment, right. And neutral point is defined to be the point about which the moment on the entire aircraft from wing, tail, elevator, blah blah, everything is 0. It is balanced about the neutral point. Okay. So, you go and plug in that information that if I calculate the moment about the neutral point, I should get 0 moment, it should be at maximum angle of attack, and my elevator deflection should be a negative 25 degrees. Okay. By the way, you all missed that you needed neutral point. Only one person got onto that. Next, show or illustrate static margin. So, whenever you are asked to make such a figure, what is the first line that you are supposed to draw? it is fuselage reference line. I can't understand, I have told this people who took it with me in winter as well, but please, this is FRL, okay, fuselage reference line. First you draw the fuselage reference line. Now you don't need to draw the entire figure. What's required with respect to static margin? Neutral point and CG, okay. So you are going to go ahead and mark the CG and the neutral point. What else should be required? You will go ahead and find out the values of xCG and x neutral point as well. So you will have to fix the wing somewhere and you will have to show that this is XNP and this is XNC. Oh sorry, what am I saying? XCG. If these things are missing from your figure, then I can't make heads or tails. Like I could randomly put neutral point anywhere on the fuselage reference line and CG anywhere on the fuselage reference line, right. I need to show that this is a stable aircraft that we are analyzing or maybe an unstable aircraft that we are analyzing, right. If the aircraft turns out to be unstable like a fighter jet, which is an unlikely scenario that you will get that in your midterm, but in case you have an unstable aircraft, the CG would be behind the neutral point, right, and then you have to show me the distance, how is x neutral point and x CG defined, because finally what has been asked to illustrate the static margin. And what is the static margin? Don't forget to show the static margin, okay. So this is, it's clearly visible here, right. Yes. Any questions? So this,
like this diagram, right? Does the x-axis start at like the aerodynamic center of the wing?
no, the leading edge of the wing.
Oh, the leading edge, sorry.
So this more or less covers everything regarding longitudinal stability components, tail, elevator, wing, okay. Now I will play a little bit more about graphical usage. So remember that lecture 4 or lecture 5, I don't know exactly, Professor Taha has dedicated one lecture entirely to graphical examples, if you remember, right. What happens when you deflect the elevator, the CMCL curve goes down or the CM alpha curve goes down. So remember that in flight dynamics, I have seen that a lot of students, including myself when I was an undergrad, get confused when CMCL data is given. Okay. So let's say sometimes something like so let's say something like this is given to you. Three, 4, 5, 6, 7, 8, 9, so on and so forth, 0.4 let's say. This is 1 and this is CM versus CL, okay. Now don't worry about the question could be about anything. Let's dissect and extract as much information as we can from this graph, okay. First of all, forget that first of all, what are some of the important points here that I can directly obtain from this graph? Slope, excellent. So this is DCM versus DCL, which is Cm alpha divided by Cl alpha. Ring a bell? So, if you know the average chord, then you can just use this graph to go and find out the static margin. Looks absolutely unrelated, but just from this simple piece of diagram, you can go and find out that how strongly stable is the aircraft, how far away is the neutral point or ahead of the CG. Okay. What else can we extract? Where does the graph cut the x axis and where does the graph cut the y axis, right? So, what does this mean? Let us look at the x axis or the CL axis. So, it is cutting it at 1.0. So, what is the Cm here? It is 0, right, which means CL trim is going to be, any doubts? Okay. And what is the CL here? Which means that Cm naught for the entire aircraft is that clear? So, this is all the information you can extract from this graph. Similarly, same thing could have been done if alpha were given. It is not going to be much different, to be honest. Why? Because look at this, I can write dCm by dCl as equals to dCm by d alpha times d alpha by dCl, which I can invert to write dCm by d alpha divided by dCl by d alpha, right. So, if I was given the graph between Cm and alpha, right, and I could find out dCm by d alpha from the graph, right, which means I could find out Cm alpha from the graph, and obviously if lift coefficient is not given to you, I have told you that you can assume 2 pi, go ahead and find out the aspect ratio. I am very sure that there will not be a question where aspect ratio is also not given and lift coefficient is also not given. Okay. I can vouch for this, that Professor Taha will never give you a question where both information is not available. Either the lift coefficient 3D will be explicitly written down or the aspect ratio will be given to you, so that you can estimate using 2 pi, right. And this is CL alpha, which you can find in any circumstance. So, if now you have this, which means you can again go ahead and construct the static margin. So, be it Cm versus Cl or Cm versus alpha, you can look at the graph and go get the static margin, right. Then x intercept would be alpha trim, right, the operating alpha for the trim point, and obviously this would still remain the same. This is Cm naught, right, at 0 alpha, which is the constant contribution, constant part of the pitching moment for the entire aircraft. Okay. Now, what other sorcery can I do with this graph? Let us look at it. So, this is single graph. Okay. Now, I will make again I will make the same graph again, but this time with a little different motivation. Okay. This is 0.4, this is 0.6. So, now I was flying at, what does this mean? That let us say I had a flight which was very comfortably flying at, let us say 17,000 feet, okay, and at 17,000 feet my CL trim was 0.6, okay. And obviously, because I have to fly at a certain speed, I can't like fly at smaller speed. My FAA directs that I keep flying at 450 knots or something, 400 knots. Okay. So, I can't change my speed, I can't change, I have to fly at that speed, but now the air traffic controller is telling me that you need to go to 35,000, you have already taken off, need to go up. What will happen when you go to 35,000 to the density of air? It will go down, which means that to balance the same amount of weight, you will need a larger CL trim, right. Now, tell me that if this was the graph of the aircraft, how can I operate at a larger CL trim? Because let us say I operate at 0.95, then at 0.95 I have to encounter some negative pitching moment, right. The moment I try to fly at 35,000 feet, my aircraft will want to come down. So, what will help me here? Elevators, right. And to counter negative moment, what and you both will not say now and neither will you say. To counter negative moment, what should be the deflection? Upward, downward? Up? Yes, up. Even I have to take a minute. So, if you deflect it up, the lift goes down. If the lift goes down, then about the entire aircraft you pitch up. Okay? So, up means positive deflection or negative deflection? Negative deflection. Okay. You guys are doing well. I was still confused on my midterm. So, what does this mean? That now I need to apply some negative deflection, right? And now what do you think naturally the question will ask?
What would be the maximum or the necessary deflection?
What would be the sign deflection for the aircraft to now operate at CL trim of 0.95? Okay? And that has to be positive or negative. You have to figure it out yourself. Don't ask me in the exam. I am going to read a math book at that time. So, you do your exam, I will do mine. Now, what if I was coming down, let us say this was my original graph and I was coming down from 33,000 to 17,000, the opposite thing. Like if this was delta elevator 0 degrees, then this would be some delta, positive or negative? And any graph below would be? So, etch this into your head that the CM CL or CM alpha, right, because CL is a fixed thing, right, it's only for force, it's not a moment, does not depend on location. CL is solely dependent on alpha. CM is not only dependent on alpha, it is also dependent upon the moment, upon the point from which you are taking the moment, because it is a moment, right. Moment is given as r cross f. Lift is a force, not dependent on distance. Moment is dependent on the momentum, right. So, whether this graph be CL or alpha, I do not care, right. It is the same thing. Essentially, I have just shown you that you can derive DCM DCL from CM alpha graph as well as from CM CL graph. And then the last thing that is very crucial to understand in this graph is that if you give a negative deflection, your curve moves upward, and if you give a positive deflection, your curve moves downward. Okay? And this is what is required. Basically, this is how more or less the question is going to be framed, that we want to cruise at some, the word trim might not be there. So, do not get confused. We might want to cruise at 0.5, we might want to cruise at 0.85, we might want to cruise at 0.3. So, cruise means your aircraft has to be in trim condition. Is it clear? And then if we want to grill you more, then probably we are also going to ask for most forward CG limit, which you can still get from the graph. Any idea how? The slope. Okay. Any other questions, you can get CM alpha and then CM alpha can be related to CL alpha can be related to static margin, and you can go back to most forward CG limit. Yes?
Can you explain one more time how like the slope would work if you're going from CL graph or a CM alpha graph?
Yeah, definitely. It's difficult to get it the first time. So look at this. Are you comfortable with like differentiation and stuff? So forget about the graphs first, okay? Forget about the graphs. Let me tell you a different story. Forget we are studying flight dynamics, absolutely. I am telling you that I have a function y which is given as x cube plus x, okay? And then x is given as x is given as mz plus c, where m and z are m and c are constants. Is this new notation for you, or have you seen this before? You've seen it, right? They are constants, belong to real numbers, and z is a variable. X's value is dependent on z, and y's value is dependent on x. Okay. Now, if I have a graph for y and x, I could go ahead and find out dy dx, right? And if I had a graph for x and z, I could go ahead and find out dx dz. But what if I had a graph for y and z? Could I not find out dx, dy, dz? I can. Why? Because this is nothing but dy dx. If I divide it by dz by dx, which is I invert this and multiply, I get dy by dz, right? Same thing. Cm is equals to Cm naught plus Cm alpha times alpha, which means that dCm by d alpha is Cm alpha, Cl is Cl naught plus Cl alpha times alpha, which means dCl by d alpha is Cl alpha, right? Now, if you divide these two, you get dCm by dCl is Cm alpha by Cl alpha, right? But remember that this relation is coming from these two relations, because alpha is actually just linear in terms of Cl, right? Here, oh my god, disaster, nobody stop me. Imagine flying on elevators. So this is the moment, this is your alpha, right? But then there is the tricky part here inside Cm alpha, which has the Cg term inside of it, the Cl alpha times xCg minus xAc by C bar, remember? So this is where Cg is hiding, xCg is hiding inside that, always remember. It's not just a function of alpha. This is a constant entity. This is only a function of the geometry of the airfoil, nothing else. Once you fix the shape, position, design of the aircraft, Cl alpha is fixed forever until the aircraft is retired. Here xCg minus xAc is a hidden devil inside Cm alpha, don't forget that. That is why Cm alpha most forward has to be calculated when you are doing xCg most forward. Got it? Anything which is not clear, this is the moment. This graph is very important, understanding Cm, Cl. Yes?
How does XAC turn into XMP? How does XAC turn into XMP?
Where?
The neutral point. How does the aerodynamic center fit the neutral point?
Here?
Yeah.
The definition of static margin has neutral point, but if you go and review the wing and tail contribution, the moment contribution coming from the wing is Cl alpha wing times xCg minus xAc by C bar. So I am saying that inside the expression for Cm alpha, like you are going to expand Cm alpha like this, contribution from the wing Cm alpha, contribution from the tail Cm alpha, right? And this part has Cl alpha wing times, which is equals to xCg minus xAc by C bar plus the tail contribution.
So it has nothing to do with, so you can't derive the negative XMP
Oh, you can derive it. You can derive it by placing moment equals 0. So it is saying that don't confuse both the concepts, okay. This is wing's contribution about the CG. Now if I wrote my moment about neutral point, right, remember that let us say this is the CG, this is the neutral point, and this is the aerodynamic center of the wing, okay. When I write down the moment for the entire aircraft, I am always writing about CG. So all these contributions that you have studied, contribution of the tail, contribution of the wing, contribution of the delta, these are all with respect to CG, okay. Wherever it is mentioned lift of the aircraft, moment of the aircraft, always with respect to CG. Neutral point is a concept we introduce, that if now you forgot the CG and wrote the moments about the neutral point, right, then you would get 0 total moment. And then we equate both the facts that the moment about CG is this and 0 moment about neutral point is this. So, can I relate these two things? From there you get static margin. So, basically if you write down the moment about CG, you will have a term like xCG minus xAC, and if you write down the moment about xNP, you will have a term like xNP minus xAC. Then recall that you subtract them, and that is where you get xNP minus xCG, which goes into the static margin. Okay. Review all these notes, like it takes like 5 minutes to go through each lecture 1 to lecture 6. Yes.
Is there like on if we're given on these graphs, is there like a moment or like a point on these graphs where it's like indicated where xCG most forward is, or like how would we go about finding that if we were given this?
Oh, like not about this graph. I was saying that if you were given a problem which has xCG, it would be a different variant of a problem. I should have been more clearer. And in that variant, you would have something like this. So if I told you that this and like these are the operating Cm alpha slopes, and the aircraft operates between them, can you tell me that which one would correspond to maximum CG limit? Which one? The highest negative Cm alpha, okay, which would be this one. So if you follow on this slope, if you take the slope of this one, so this is going to be, so think like what's happening at maximum at landing, you are facing maximum negative pitching moment. Everything is going negative. Thus, the aircraft wants to go pitch down. You are stopping that from happening, right? So just keep the physics in mind. The math will fall into place. Okay, math is a language. It's more than a language. Mathematicians will disagree, but math is a language in engineering. Okay, and quickly, do I have time? I don't have time. Will you sit for 2-3 minutes more patiently? I have just one last. So after this, I have discussed the roll and yaw, like roll and thrust asymmetry. Go and watch last week's lecture. There is just one more interesting topic which I think is important to discuss, which is like not a part of syllabus, but just a quick concept. So you have seen single propeller planes like Cessna and all. Have you seen that they always need to use rudder while flying? Do you know why?
They naturally roll because of the
Yaw.
yaw.
Yaw. Because of, so see what happens is, let's say this was your like German Spitfire or something like that, and this was your propeller. This is the perfect alignment, that your fuselage reference line is absolutely in line with the air velocity. Okay. Then what happens is, if you were looking at from the top, the propeller would look something like this and the aircraft would look something like this, right? Then the thrust would exactly go through here, right? But rarely the aircraft flies in line with the horizontal. What is going to happen most of the time? That the aircraft is pitching up or climbing up or moving down. So in that case, what is going to happen? The velocity is going to come like this, right? If the propeller is spinning this way, right? Now let's look at the propeller which is going up and which is coming down. So the propeller on that side and this side, the one that is coming down will see a higher resultant velocity, and the one that is going up will see a lower resultant velocity, which means this half of the propeller will generate less force than that half of the propeller. So now if you look from the top, your thrust line will start passing through here, which means that if this was your fuselage reference line, now you have a yawing moment, and to cancel that, what can you use? The rudder. So again, yawing coming from the propeller should equal yawing coming from the rudder. Plug in that, and what will the question most probably ask you? Signed deflection of the rudder. So make sure to note down your signs, positive, negative, properly, and the directions. Okay, go home. I want to go home today.